Hello everyone, thanks for watching. If you found this tutorial helpful, please like, share and subscribe for more technical content. Also feel free to leave your thoughts or question in the comment below. I would love to hear from you. Let's get started. In this video, we will discussing document search using RAG and exploring some of the model and technique that can help enhance search performance and accuracy. We will cover the key concepts and demonstrate how to implement them effectively. In today's session, we will start by looking at the problem statement and the challenges of the document search. Then I will give you an overview of RAG, walk you through the system architecture and key components. And finally, we will see a demo in VS Code before wrapping up with the conclusion and next step. Uh, let's talk about the problem statement. Document search is a fundamental task in many applications such as customer support, research, and information retrieval. However, search a large text dataset using traditional keyword search often fail to capture context, resulting in irrelevant or incomplete answers. The challenge is to build a search system that can understand natural language queries, retrieve the most relevant information, and provide context-aware responses using modern AI techniques like retrieval-augmented generation. In this section, let's talk about chunking. Chunking involves splitting a large text into smaller, manageable pieces. When we search through a vast dataset, first break it down into smaller chunks, typically around a 500 character each. These this chunking process help us efficiently manage and retrieve relevant information. The result is a list of smaller text chunks that we can search through more effectively. Now, in this section, let's discuss embedding. Embedding is the process of covering our text chunks into a numerical format that the computer can understand. By transforming text into numerical vectors, we enable the system to process and search the data more effectively. Humans read and understand text, but the system handles these numerical embeddings to perform searches and retrieve relevant information. The million dollar question is, what is RAG? RAG stands for Retrieval-Augmented Generation. It combines two processes, retrieval and generation. In the retrieval phase, we extract relevant context from embedding. Then, in the generation phase, we use this retrieval context along with a query to generate accurate and relevant answer from the user's request. So now let's talk about the RAG architecture. The process starts with converting both the user's query and document text chunks into embedding using a specialized model. The retrieval module search for the most relevant chunks based on the query embedding. Retrieved context is passed to a large language model which generate a detailed and informed response leveraging both context and general knowledge. The architecture combines steps like chunking, embedding, semantic retrievals, and generative answer formulation, ensuring answers are grounded and complete. Now let's discuss the RAG pipeline. The RAG pipeline process, uh, we start by taking a query from user. The query is then converted into embedding. We use this query embedded to search through our chunked embedded to find the most relevant result. These results or contexts are then sent to the large language model (LLM). Before sending it to LLM, we create a prompt that includes both the context and original query. The prompt instructs the LLM to generate a response based on the provided context. The LLM then produces an accurate and coherent answer. Uh, in this section, we will talk about the demo. We will explore various components such as chunking, embedding, query analysis, and RAG pipeline. Let's start with VS Code, where we will have our folder structure set up for these different tasks. Now we are in VS Code. Now you can see the code over here. So first of all, let's talk about our documents. So we should have a document where we put our information. So currently I am using a text document, but we can later we can use doc, docs, PowerPoint, Excel, PDF also. I created this text file. This text file is on Kishore Kumar, a singer. He is my favorite singer, so I just put all his details over here. If you can see, document one, early life, document two, education, document three, career beginning, and this is just for an example. You can have your own data set, right? 25 documents, and currently this document is basically have only one text document have all these data, but you can split in multiple document as a text document. But we will also see in later videos, we will have PDF, Word document, and other um, document types. So let's understand uh, how we will implement RAG using this text and our large language model. So I have created two different way of understanding this code. First of all, I created a simple file where everything is in one file, right? And another way is I created using the best practices, created all in different folders, created a class interfaces, whatever is required. So if you can see, there are, let's understand the this one, the bigger one, where I have segregated this in 5 different sections. One is chunking. This chunking section will uh, get this file and divide it into small piece of information or text, and then we will embed this text into embedding section, and then we will query from embedded text and embedded chunks, and then we will process from RAG, and we'll call all these information in the main file. So let's understand one by one. If you go to the chunking, I created a chunker.py file. Here you can see a class called chunker. This class has two methods. One is constructor. Constructor we are passing chunk size. Mostly by default we use the 500 characters as a chunk. So that is we make 500. You can use your own size of the chunk. And another method is chunk text. In this method we will divide our complete text into small piece of chunks. How we'll do it? You can see our chunk size is 500 characters. So if you can see, range 0 to length of the text, and chunk size 500. So how will it work? Then it will divide our text into I, first of all 0, 0 to 0 plus chunk size 500. So it will divide 500 character in the first chunk. Next it will be 500, and 500 plus 500, 1000. 500, then 500, then 500. Each string will have 500 characters in one chunk. So it will return a list of all 500 chunk in each list item, right? So this will be in this section. What we are doing is we are just getting our text file, this Kishore Kumar text file, and we are just dividing each uh, text into 500 characters as a list, and then this list will be returned from here. So we will use this chunking in our main file. I'll show you where we are using it. Then once chunking is done, then we have the embedding. Embedding, what we have already understood. We understand the text format, but computer can understand only the numerical form. We can also call it vectors. So the embedding section, we convert these text into vectors, numerical form, so that the computer can understand. So again, the embedder has three method. First is constructor. In the constructor, we are passing a model. This model is Hugging Face model. This is basically deployed in Hugging Face. All mini LM hyphen L6 hyphen V2. This model will help us to convert text into embeddings. So next method is embedded chunks. So in this section we are passing chunks and self. Self is the constructor whatever we have defined here. So chunks is basically coming from chunking when we have already chunked our whole text into list of chunks, and this list of chunks will be passed here in embeddings. And then what we'll do is we will use self.model.encode. Encode is basically encode our characters or the all the list of chunks into embeddings, and it will return embeddings to us, and we will return this embedding to this method from this method. And next method is embed query. So we have embed our whole text, and then we will embed the query. Whenever we are typing, the end user will type any query. First of all, we need to embed that, because the all text is already embedded, and when a query will come, query will also embed, and then we will search from the embedding only, right? So we will embed here. So if you can see the difference, self model dot encode chunks, but here self dot model encode brackets query and 0. What does this means? The encode always have the list of strings, right? So here we don't have the list, we have only one query. So that's why we convert this one string to a list, one list, and then we will uh, return as a first when it will encode, because it is a list. Encode return a list of character, but because we are passing only one string, then we should get the first embedding from the models, right? So that's what we are getting our embedding query embedding from this method. So once we have converted our chunks into embedding and query into embedding also, then we'll go to the query. If you click on the query engine, we name it query-engine.py. Here we are importing the cosine.similarity from sklearn.matrix.pairwise. We will search the similarity search from embeddings. So how we'll do it? First of all, again, the query engine has the constructor. We are passing embeddings and chunks and embedding both we are passing, and we are initializing embedding and chunks here. These will be used over here. So another method is query, where we are passing self, this one, and query embeddings and top K5. Why top K5? We always use top 5 search text, similar text. So because it written a lot of list of results, but we will use only top 5 chunks, that is perfectly matching to our chunks. The query is matching with the chunks. So that 5 chunks we will get, right, using top K5. We will see how we will do return the top 5. So first of all, the if you can see the method cosine similarity, in the cosine similarity we will pass our query embedding and self dot embeddings. Self embedding is what? Self embedding is our embedding that chunks, whole chunk is embedded, and this embedded will be here, and from from whole embedding we will search query, the query we are passing here. So this query will be match match within this embeddings using cosine similarity. So how it does? It will search, you know, the similar search, whatever we are passing, that similar search will be done in the embedding, and give the result from embedding here. It will give you the score of the result. So that score we will have, and then what we will do is we'll get only top 5. How we'll use the numpy dot arg sort? This method will return only top 5. How will return top 5? Top 5k, this double colon minus 1 will we make our list into descending order, and then top k means top 5. We have mentioned 5, right? And it will extract only top 5 result in a descending order that will be most similar to our results. And then we have the cell chunks, right? And the chunks is basically our main chunks. We have already divided small pieces in chunking section. That's chunks, because this top indices is basically the scores. That scores will still be embeddings, right? So we will uh, get those information from the self. This is the text, and we will match these self text from here, and then get the exact result, means the top 5 similar results from our text. Once the result is, we have the results, then we will return it from here. Now now we'll go through the RAG pipeline. In the RAG pipeline, you can see there again we have the constructor, where we are passing chunking, embedding, and query engine. We are passing chunking, embedding, and query engine. Three of them we are passing, and we are initializing chunker, embedder, query engine, and results. And also, if you can see, we are also importing the pipeline from transformer. This Hugging Face transformer, we are using a model called Google Flan-T5 base to generate our content. This is the large language model. So it says text to text generation. It means we are passing text and generating text from the large language model. And why we are using pipeline? Pipeline make our basically it reduces multiple steps. Like if we are not using pipeline is basically call the API from Hugging Face and make our work easy. Because if we are not using pipeline, then we have to use multiple steps. Like we first of all we need to tokenize the query, and then we have to infer, inference the model. We also call the model inference, and then we have to do the decoding. So those things we have to do by our own. So if we use the pipeline, all these three steps will be done in the back end, so we don't need to worry about it. So we understood, we initialize the model, and once we initialize model, then we have another method called run pipeline, where we are passing text and query. Text is basically we are passing text from here. We will extract text from the file, and then that text will pass here, and query, this query will come from the user also. So now, uh, first of all, we are using the query. This query will embed this query. So we are passing this query here, and we are calling self embedded, or embedding means first of all self is this one, then embedder is this one, and this embedder is calling our this embedding method, and then we will use embed query. If you can see this embed query, this method we are calling from here, embed query, where we are just encoding our query into embedding, right? So we will embed our query here, then retrieve chunks. So we will call query engine, where we are passing uh, retrieve chunk, then we are calling self query engine, then query. Self is here, query engine is here, and we are calling query. If you go to the query engine here, and we are calling query, where we are passing query embedding and top 5, where we are getting all these results. We have already talked about it. And then we will just call self query engine and query, passing the query embeddings from here, and top 5, we are passing 5, and it will give us the list of results. This list of result, we are just we are converting that list to a string. So we are passing the relevant result, and each list item should concatenate through space. So it will give us the whole string, not a list. So this string will use as a context, because the user is saying, okay, who is Kishore Kumar? So Kishore Kumar, who is Kishore Kumar, will be embedded here, and pass this into the query engine, and then it will search, and it will get 5 more populist or matching similar matching results, and that results will come here, right? Because this 5 result is not making a sense actually properly, so we will send this whole 5 most similar result to our LLM to generate a proper results, right? So how we will do it? So we will get all 5 text. So suppose I am asking who is Kishore Kumar, it will go to this text. It is already converted 5 chunks. Like in the first chunk, it should have this much of character. Second chunk, it should have this much of character, right? So when I ask who is Kishore Kumar, maybe it will similar search like Kishore Kumar Ganguly born. So it will result get this result. Maybe he will return some result from here, right? And it will return some result from here, like 5 chunks will return it. But if you combine these 5 results, it will not make sense actually. So to make a sense, maybe the whole context will be sent to the large language model. It will understand, and then it will give you a proper results from the large language model. So if you go to the pipeline, yeah, so once I have the context, I have asked something, I got the result from our documents, and then that result is called as a context. Now I need to create a prompt, means I need to instruct my LLM to answer. So how as good as your prompt will be, that answer will be more accurate. So I am instructing my prompt or LLM saying, you are an expert assistant, provide a detailed, informative and complete answer based on the context below. And context is this context means whatever information we have from our text. We are not getting whole file, we are just getting small chunks of matching, um, chunks, small piece of chunks, right? Those five results we will send to our LLM. And we also sent the question, what question he asked, like, who is Kishore Kumar. So first of all, I'm instructing that you can give me the, you are the expert, and you should give a detailed, informative, complete answer. And this is the context is from the document, and query is, I ask query, who is Kishore Kumar, right? So Kishore Kumar, and context is this, and then it will process in this information to our LLM, right? QA model we have already defined, and then it will give me an answer. So how it will do, this is the prompt. So I'm just calling self.qa model and passing prompt, this prompt, and max new token equals to 300. So max token, so is basically we have to restrict some input and output token, right? So whenever we are passing some input or output, that should have some limitation, because all LLM models have some limitation for input and output tokens. So that's why we have restricting it to max input or output tokens over here. So we are giving output token as max 300. Now self dot result, we have the answer, and we should have uh, first, because it will return a dictionary, right? And we need to get the first item from the dictionary and the generated text. So it will give you the accurate generated text from the LLM, and then we have assigned this to our self result. If there is no result, or there, if suppose the prompt is also, context is also zero, maybe there is nothing coming from the documents, then it will return nothing, right? So this method, we should call this method pipeline method in our main function, right? So let's move to the main file. If you go to main file, let's understand how we are calling all these processes. Like first of all, we are importing our chunker, and this one chunker from this one, because this is the class, and we are source, chunker, and chunking and chunker. Source this file, chunking this folder, and inside the chunker we have chunker class. So this way we will call, first of all, uh, parent folder, then child folder, and then the class name, right? This way we will again call other, we will import other files also, the class also, embedder, query engine, and pipeline 4, this one. Once we imported all our important classes, and then we will have our main function. In the main function, what we are doing, we are having our path of our file, this one, Kishore Kumar text. You can see here, Kishore Kumar text. and then we will open this file path. With open file path, read encoding UTF-8, right, and text. This way we will read from file text and store all these text from file to our text variable, right. If there is any exception, we will print error reading file. So once we have the text, then we will initialize chunker. In the chunker we will send 500 maximum size of the chunk, and then we will initialize embedder, and chunks we will call chunks dot chunk text. If you can go to the chunks chunker or chunks, this method will call here to converted all text into our small chunks, right. So main dot file, so we chunk dot hyphen text method is called, and we get all our chunks, a list of chunks over here, and then we are passing these chunks to the embedder dot chunks. In embedder we have embedder chunks where we are encoding our chunks into embeddings, right. So first of all we are uh, created chunk list of chunks, and then we are embedding these chunks, and then we are calling query engine. I mean to say this is, we are initializing the query engine method constructor, and passing embedding, this embedding and chunking, right. If you go to the query engine, here we have initialize the constructor, we are passing embedding and chunks, and this will pass our embedding and initialize self.embedding and some self.chunks. By just we are initializing it, when we call query, it will, the chunking and embedding will call from here only. So go to the main initialize, then we will call rack pipeline. This is again we are initializing rack pipeline where we are sending the chunker, right, chunker, embedder, and query engine, this query engine rack pipeline, right. If you go to the rack pipeline, uh, rack pipeline, we are just initializing this, we are passing chunker, embedder, and query engine, this one, and we'll use these information here in run pipeline. Now we have initialized the rack pipeline. Now we will ask question from the users like input, enter your search query. So we will enter, user will enter a query here, then query will become here, and then this query will pass the whole text, and query will pass into a run pipeline, rag pipeline. If you go to rag and run pipeline, it will have the text and query. Using the text and query, we will generate the prompt and get the results, right. So we don't need to print the chunk and the numbers. So what we'll do, we will print the search result over here. We are passing a query based on our documents. It will send all our context to our LLM and will print over here. So let's see, let's run this and see. Again, this is one of the things. Another one, if you want a simple pipeline, I just create a simple file. I will just give you in couple of minutes. I will make you understand. Like I just import sentence transformer, cosine, similarity, numpy, and transformer as a pipeline. So we create a he in this file. I don't create class and constructor and all those things. It's just a one file. Created couple of method like chunk text. I'm just uh, splitting text into chunks and return list of chunks from this method. Embedding, we are passing chunks and model. The model will encode our chunks and return the embedded chunks. And embedding query, we are passing query and model. This will embed our query and return the embedded query. Another query chunks, where we are passing query embedding, embeddings, chunks, and top. Query embedding, the query the user will ask that we converted to the embeddings. The embeddings, we have the chunks. The chunks will be converted into embeddings. This one, embeddings, right? This comes from here. This embeddings comes from here, and chunks is basically we have from here. Top 5, we will get top 5 only. So we have already discussed cosine similarity will search and give us similar search from the embedding. I mean to say, it is not search, it will be the score of the similarity search. So that scores will be sent here, and will have top 5 similarity search, accurate search, and we will make this descending order, and then get top 5 similar search here. And then this will be passed into our chunks to get our results, like context, right? 5 context we will have, and we will convert this list of context into a string, so that we can pass it to the LLM. So once we have we return the means result, then we will have the pipeline run rack pipeline, where we are initializing sentence transformer model AI mini LM L6 V2 model. We will initialize here as embedded model, and then we will have the chunk. Will call chunk method. It will divide into a small piece of text and return as a list. And then embedding, we will embed our these chunks into embedding and return the embedding. We can call embedded chunks. And then we will pass our query and call this embedded query to embed our query into embedded query. And then we will call our query engine to pass our embedding, query embedding and embedding, to get the results. So we will have the chunk result, top 5 results over here, and it will be a list. Then this list will be converted to a string, as we already discussed. And then we will pass this context into our model. So first of all, we will have to initialize the model using the pipeline. As I said, this will make our work very easy. We need not to use the tokenization and model inference and decoding. So all these things will be done by pipeline, and we will have more examples on those things, like tokenizing and tokenization, model inference, and decoding. We'll have more videos on this kind of topic. So here pipeline will initialize the model Google hyphen Flan-T5 base and device -1. So why we mentioned my device 0 means, if you have GPU, then you can use GPU and you have to set device equal to 0. If you have CPU, you can mention -1. If you have CPU and GPU, then you can decide which one you want to use here. And if you can have secondary GPU, then you can use 1, 2, 3. This way you can select which processor you want to use here to generate your content using this LLM, right? So as we already said, text to text generation, this model will be used to generate your content. We will pass text and it will return a text from the model. Now we'll see if context has nothing. I mean, it returned empty string. Then we will return nothing, I guess. If this, right, strips means if it has some text, then we'll create a context prompt. How will create prompt? We will instruct LLM model. Similar, these things we have already discussed here, so we won't go deeper into it. So in this way, we will create a context prompt, and then we will pass prompt into this, and because prompt has all context and query, and then it will give me answer, and this answer should get, from this answer we should get first item, and that item should have generated text, and this result we can return from here. And then we will have the main. In the main we can pass our file path, and we'll open the file and get all this text over here. If there is an error, we will print the error, and we will get the question from the users, and then we will run the pipeline using our text query and chunk size. It will return us chunks and results, right? And then we'll print results using, if result has some text, then we print it, otherwise it will say no result found. And then we will run the main from this. So let's run this file and see how it will give you a result. Let's say python simple pipeline.py. Just I'm running it, entering. Now it is asking me to enter a query. So let's say who is Kishore Kumar. Now if you can see, it says device set to CPU. Why it says CPU? Because we are saying device equals to -1. If it is 0, then it will say device set to GPU. Most probably most of us don't use GPU as of now. It is very costly. So if someone has the GPU, they can use it. But in my system, we are using CPU only. And then it says token indices sequence length is lower than the specific maximum sequence length for this model. 634152, running this sequence through the model with result in indexing error. This means actually we are passing 634 tokens, not, and this model accept or has a limit of 512 tokens only, right? So we are passing more token than it accept, but still it is giving an uh, result like Kishore Kumar Ganguly was born 4th August 4th 1929 in Khandwa, Madhya Pradesh, and for from an early age he showed interest in music and performing arts. So this way it will give you a result. It is not just matching with what it has in the text. You can say some different result over here, because we are passing those context to a LLM. LLM will create a content for you as per, the LLM model is trained. So let's ask some other question. So let's have another question. What are the most popular song? What are the most popular songs of Kishore Kumar? Now you can see the result is मेरे सपनों की रानी पल पल दिल के पास एक लड़की भीगी भागी सी and रूप तेरा मस्ताना. If you can see, maybe if suppose if I copy most popular songs in in our here, you can't find it. Most popular song, even most popular playlist singer, but most popular songs not in this. But how it works actually? So when we are querying, it will get our question and it will go and search from our text more similar search. It will not exactly match your keyword. It will not match, it will match the similarity, right? Similar words or tone. So this way it will get the result and we will pass those five top results into our LLM and LLM will give a result as per the information we have passed. Again, this error maybe once we have another video where we will showcase the tokenization, model inferencing and the decoding, then this token error will be gone, or we can reduce our input query. I mean to say, the context, all these input is more than 5 12 tokens, so we can reduce those or text and then put into uh, the LLM to get the better answer. Now you can see the readme where I have given some details over here how it works, like document search with rack, features, project structure, installation guide, usage, example flow, and some requirement and notes. Apart from this, I have the requirement.txt where I mention what frameworks or tools we need to install. So we have all these information here. You just need to run a command like pip install -r requirement.txt and then everything will be installed in your machine. So the demo is done. Let's move to the slide. So demo is done. Now next, set up a requirement. So if you want to run this code in your system, then this is the instruction you can how you can set up this code in your system and run this application. So first of all, you have to have this Python version 3.14 or more and some essential libraries like transformer, sentence transformer, scikit-learn and numpy. Installation, how you will install these all things. So I have created a requirement.txt. This requirement.txt, you just needs to run this command pip install -r requirement.txt. It will install all your essential libraries into your system. Then you can just run this code. And optional GPU acceleration, as we already discussed, 0 means you want to use GPU. If you set -1, then you have to use your CPU only. Next, summary and next step. So we have already given demo, understand the RAG systems. Now what is the next? So next is we can integrate vector database like FAS, Pinecode, VV8, Chroma. So a lot of vector database we have, AWS Open Search. A lot of vector database we have. So comment or give your suggestion, and then we'll definitely see more people are more people have interested in integrating the vector database. We will pick up this one and create a video on this. We can also explore large language model. Currently, we are using some small large, not that powerful, but more than, because all large language model is trained with millions of parameters. So based on the million of parameters we can use. So this is we are using Flant um, base one, right? So we can use Flan-T5 large or Flan-T5 XL. We can use GPT or other Llama model also. So we'll talk about later. Slowly we will go and see more model being used in our videos. Next is develop a user interface. So definitely we can also go and develop a user interface so that we can directly chat with our agent or chatbot. So we need not to depend on the command window. So just I need your suggestions. It will be help me to choose which one you want to implement. That's it for today tutorial. You know how to build a document search system with RAG using Hugging Face Transformer, Sentence Transformer, and Flan-T5. If you found this helpful, don't forget to like the video, subscribe to the channel, and share your thoughts in the comment. The complete code is available on GitHub. Link is in the description. Thanks for watching. I will see you in the next video.